Hello everyone. I previously discussed that the differences between each of the arithmetic sequences. So for example, we had an arithmetic sequence, a Fibonacci sequence, and a quadratic sequence. These are the three most likely sequences that will come up in your exam, that can come up in your exam. So if an arithmetic sequence is when the difference between each term is constant, and it's the most straightforward one. So for example, the nth term is when it's determined by minusing 3 from the term before it. So 17 minus 3 is 14, 14 minus 3 is 11, and you go on and go on and go on. A Fibonacci sequence is when you look at the two terms before it to make up the next term. So for example, 1 plus 2 equals 3, 2 plus 3 equals to 5, etc, etc, etc. And then you have a quadratic sequence, which is when the and with Fibonacci sequence, the differences between each term is not constant. For a quadratic sequence, the difference between each term is not constant as well. Okay, so these two you can say are not constant. Okay, but this one is constant. Okay, but as you can see, the difference between the differences, so let's just say this is the difference. Okay, I'm not gonna write the whole word, but you know it's gonna be the difference. And then this is the difference between the differences. So let's just call that dd. dd is the same. Okay, so the differences between the differences are the same. So they're going up in a steady amount. So this is gonna be 4, 4, 4, and it's gonna carry on going 4, 4, 4. So how do you solve these questions? So this one is quite straightforward. So you just get the difference between them to give you 3n minus 3n, sorry, 3n, and then you see how much. So let's just say if n was 1 for the first term, how that would give us minus 3, right? But clearly the first term is not minus 3, it's going to be 17. So you have to do plus 20, because minus 3 plus 20 is going to give you 17, and that's correct. You can double check your answer by choosing a random sequence, a random term in a sequence. So for example, let's just choose this term, which is the fourth term in the sequence, which should give us 8. So if you put what do you call it? If you put 4 into this equation, what's it going to give us? So it's going to be minus 3 times by 4 plus 20, which is going to give us, what's this? 12 minus 12, so 20 minus 12, which is going to give us 8, and that's correct. Fibonacci sequence, you just carry on. So they wouldn't ask you to find an equation for a Fibonacci sequence. They would just ask you to find maybe the fourth term, so the sixth term. Sorry, let me just rub that out, because that's incorrect. They'll ask you to find the sixth term, so let's just put 6 up there, because this is the fifth term. So and the sixth term would be what? What would be the sixth term? It will be, you have to add 5 to this one, because it's going to be 5 plus 8, which is going to be 13. And the seventh term, etc, etc. And then lastly, quadratic sequence, and this one is the one that most people struggle with, and it's because you have to, at the moment, a quadratic sequence, as you know from your quadratic formula, is going to have n squared, some coefficient in front of it. So n squared plus an n, because what do you call it? N squared plus n plus c, for example. And this could be 0. This one can be 0, but it could also have a number in front of it. So it could have, for example, 6 in front of it, for example. Okay, but I'm not saying that's what the answer is. I'm just giving you an example. Okay, now a quadratic sequence. How do we work it out? So you do. We know that the difference between the differences is 4, which means that the coefficient in front of the n is going to be 2. So 2n squared. Okay, when it's whatever dd is, in this case, I just came up with this name, by the way. It's not mathematically called dd, I'm just representing it as dd. Whatever the difference is between the differences, Okay, whatever that is, you divide it by 2. Okay, and that's the coefficient. And then you have the nth term. So let's write down the nth term again: 2, 10, 22, 38, and 58. Okay, and then we have to put down, because this is the first term, maybe it's probably better if I do it in a different color. It's the first term, second term, third term, fourth term, and then the fifth term. Okay, so let's put 1 in here. So 1's going to give us what? It's going to give us 2. When you put 1 into here, 1 squared is 1, times by 2 is 2. And then let's put 2 in here. 2 squared equals to 4 times 2 is 8. The third term, 3 squared is 9, times by 2 is what? 18. The fourth one is going to be 32. The fifth one's going to be what? 50. Yeah? And then from there, let me just change the color. We have the nth minus 2n squared. Why am I doing that? Is to remove, I'm trying to remove the squared factor from the nth term to make it linear. Okay, so the first term is going to be 0, the second term is going to be 2, the third term is going to be 4, because 22 minus 18 is 4. The fourth term is going to be 6, sorry, and the fifth term is going to be 8. Okay, now we have that. We've gone. This now is a linear equation. Okay, sorry, linear arithmetic sequence. So look, it goes up in a specific order. So plus 2 in a constant order, plus 2, plus 2, and lastly plus 2. This is no different to what we had here. They're exactly the same. Okay, so and therefore the way I'm going to calculate it is also going to be exactly the same. So that we're going to have n with a coefficient. The coefficient is going to be plus 2. Similar to how this was minus 3 here because of this. And now because that's n plus, so 2, now because it's 2n, if I put 1 in there, is it going to give me 0? No, it's not. So what do? I have to minus 2, because if I put 1 in there, it's going to be 2. Then minus 2 to get this. Okay? And you can double check your answer by putting in, let's just say, the fourth term and making sure that it's correct. The linear term is correct. So for example, 2 times by 4 minus 2. Is that going to equal 6? Yes, it is. 2 times 4 is 8, minus 2 is 6. Okay, now what's the final equation? So what's the final nth term sequence? It's going to be, we have the 2n that we removed from the initial, from here. Remember? We removed it and then we calculated the rest of it, which is this. So now we have to combine the two. Okay, so it's going to be 2n squared plus 2n minus 2. And we can double check this. So if we put 1 in there, what's it going to give us? 2, because 1 squared is 1, plus 2 minus 2, which is 2 plus 2 minus 2, which is equal to 2. And that's what we can see here. We can check it with another number, for example 4. Let's do 2 times by 4 squared minus 2 times by 4 minus 2. So this is 16, which is 32 at the end of it. 4 squared is 16 times by 2 is 32, minus 8 minus, sorry, that was plus 8. Plus 8 minus 2. That's going to give us 38. We'll know that's correct. Now you know the difference between each of the sequences and how to determine which one's which.